Right now we begin from where we stopped previously on tutorial on hashing, and today we'll be building perfect hashing. In the previous tutorial, that is tutorial 6, we discussed perfect hashing, where we mentioned that you need to maintain two hash tables, so more like you are doing hashing with chaining, but instead of using a linked list for the second hashing, when collision occurs, you use a second hash table, making it necessary to have two hash functions. So let's now see how it works. We are going to go through the algorithm step by step and then see what we can understand from there. All right, so I'll remind you to subscribe if you've not subscribed. Also, let me know anything you would like to learn or something, any challenges you're having in your program, computer science, any course at all. Just let me know in the comment box below and I will assist you for free easily. All right, so let's see. So building perfect hashing, let's run through the algorithm to see how it works. One thing you need to remember is that there has to be two hash tables. So let's look at the first step. The first step says you need to pick H1, which is from the universe of the universal hash family. We've discussed universal hash family. If you don't know about it, look at the previous videos and in the description box. You see a link to this previous videos. So you pick H1 from the universal hash family that maps to. Sorry, this is not right. That maps to from 0 to m minus 1. So H1, which is I, goes from 1 to u minus 1. So you are picking any of the function among the universal hash family and maps to the first table, right? Good. So from the universal hash family, where m is equal to order of n. So I hope this is clear. So in step 2, for each slot j, let me get this. For each slot j, 0 to m minus 1. So this one is the second level. So this is I. The first level I goes from 0 to u to m minus 1 for sure. So the second level, you are picking, this time we are taking all the items that hash into the second table. So for each slot j in 0 to m minus 1, this is the second level. So let's define Lj as the number of keys that hash into slot j. So I think, okay, let's get it clear. The first thing you do is to pick a hash function to hash into the first table. So the next step, for each slot j, and j is in 0 to m minus 1. Okay, so at this point we are talking about, so for each slot j. So I think we are still here for each slot. So we're talking about the slot. So for each slot, let's say for this slot, Lj is number of keys hashing to slot j. Good. So let's say number of keys hashing to this place. So number of keys hashing to this place. Number of keys hashing to j is given by Lj, right? Good. So how many keys will actually hash into Lj? Because if we know how many keys is going to hash into slot j, I mean, not Lj, slot j, I is actually in the universe, right? J is the number of keys, Lj number of keys hashing into slot j. Good, so j is actually the size of this table, the first table. A little confusing, but maybe you to try to pause the video and get your head around it. So how big will this table be? So this table we are talking about, how do we assume the size of this second table? J. So J is number of items hashing to slot J. So we are saying that what will be the size of J. So how do we determine that? What we are going to do is to choose the second hash function h2 of j, also from the universal hash family, but in this case is going to map to 0 to lj squared minus 1. So what we are saying is that size of second table is equal to lj squared. How it came out to be LJ squared, I'm not going to prove that at this point, but take note that in built-in a perfect hashing, the size of the second table will be LJ squared, and LJ will be the size of the number of keys hashing into one slot, which effectively is the size of the second table. Not really. So lj is number of keys that hash into slot j, right? Then we are building a table of size 0 to l squared minus 1. So the size of the second table is going to be lj. Maybe I'll try to make another presentation to clarify this. Now there might be collision that will occur either in the first or in the second table or in the second level. So how do we manage the situation? If lj squared, the sum of lj squared is less than some constant times n. So n is the number of keys among the total number of keys, and n is the total number of keys. So I'm going to write it out. This used to be a little confusing, but just take some time, it becomes clear. L is equal to total number of keys. So if the total number of keys times a constant, and you have summation of lj squared, and we are saying that lj squared is the size of this table, of the second table, then we now go back to pick another hash function. So this tends to control collision in level 1. Okay, so in level 2, what if collision occurs in the second table? So what do? We go to the next one. So while h, let me display the table so that we can see good. So while h2j, this time we are in the second level, while h2j for ki equal to h2j for ki prime for some j where ki is not equal to ki prime. So what we are saying here is, if in the second level there is a collision, if two items hash from the first level hash into the same place in the second level, and if this happens, it means that they already also h1 also hash into the same place from the first level, right? So, and eventually there is a collision in the second level table, so you just rehash this one. So simply choose another h2 from the list of from the universe. This is a bit confusing. I'll rather say maybe we can do this lesson again. I'll try to find a way to make it a little easier. So the next thing we are going to consider is how long does this take? More like we are going to do the time analysis of perfect hashing, and we're actually going to prove that it takes constant time uh, with no collision at all. There will be zero collision in this case. Well, I'd like to thank you for viewing. I'd also like to thank you for being here, for learning. And I will say in the next lesson, which is tutorial 8, where we are going to discuss how long it takes to create a perfect hashing using a two level of hashing.